Good evening. So I'm back home, and I actually got home Friday night. Tonight is Sunday night, and I actually wanted to do a video yesterday, but I was still feeling, tired from being in the hospital for the week and that sort of thing. And otherwise, my health is improving, and I'm glad that the good people at the hospital were able to help me. And then now the most important thing is I would like to really thank all of my YouTube followers and subscribers who actually posted on my community post when I posted a picture that I was in the hospital for the wishing well comments and your genuine support. It touched me, and I'm very grateful for every one of you who saw the community post and who responded to it. You guys are awesome. Thank you so much. Tonight, I'm just going to make a fairly short video with 3 segments. The first segment is I wanted to show you the Bosch pressure gauges I was able to obtain, which were used by Bosch in R&D projects and in their custom-built calibration fixtures during the manufacturing process. This is something most people probably have never seen, and I will explain that a little bit. Then some of the flow sensors came in from the Chinese manufacturer I had contacted about 3 weeks ago. They will probably not be suitable for what we want to do, but I'm going to present them anyway. And then I got the new tubes in for Mercedes-Benz for the vacuum system, basically for the intake system for the idle speed. And I wanted to just show you them. But again, I would like to thank everyone who wished me well-being, and I'm on the way to recovery. I will have to go get another CT scan next week. And I hope I won't need any surgery, that the medication and everything else I got will do the job just right, and we don't have to go into surgery in a few weeks from now. It looks like it at the moment, and if everything keeps improving with the way it is going, we will be fine. So the first segment now is going to be the Bosch pressure sensors or pressure gauges they used, not me, but I was there when they built these things, and I did the electronics when they needed electronics for those type of systems. Thank you. So this is now the first segment of our video here. And as you can see, I got original Bosch packages. And I have to probably explain this a little bit on how this worked. Bosch they're pretty much a self-sufficient company. That means they can produce almost anything what they needed. And like in the case for circuit boards for R&D test fixtures and for manufacturing test fixtures, for the manufacturing processes of several different parts and components, what they build it, they would consult with a company like what I do, and I would design the circuit board for them. Sometimes they needed 10 circuit boards, sometimes we just made 1 circuit board to test something and that sort of stuff. In this process, since my company was only about 2 miles from the Bosch World Headquarters, I had shown you in my other video up on the Solitude mountain or hill, basically where they're at. That's where their R&D center was, their primary R&D center. And this is where all of these products we're using and talking about were basically engineered. And these are some real rare goodies, which I was actually able to get off eBay, and I was surprised. But the most rarest one of all of them had to come from Germany, from a Bosch employee or former Bosch employee. And this is the system they used. I shouldn't say we used. First of all, this is what a Bosch-made gauge looks like. And these gauges are only for internal use. They were not sold because they made themselves, they were made by Bosch for Bosch. And they were not exactly available like those to the public. And had a very high precision. They were built to DIN standards. And on this one here, we also have the rather rare mounting bracket. And the way this mounting bracket worked was that they would use a metal panel as a back panel. And you can see this, we have these spacers here. And I think these are M4 threads in here. And they had a template for it, and they were simply mounted like this on the back panel. And then you had quick disconnects, I think for the 7mm connections lines, and they're simply just pressed in like this here. It's hard to do, but when you have the hose actually in here, I don't have a hose right now, you can simply depress them and then take them out or put them together. And these hoses, these brackets here, had this Bosch part number. That's a 827001882. They had, of course, different styles of brackets with different spacing. And this is how they would basically design a test setup for R&D purposes on the fly, where you can reroute lines and test something. And then you can use them with different, this is a, pressure ranges. This is a 16 bar, this is a 10 bar, and then we have two smaller ones here. And you can see this, they're basically exactly the same mounting here. And basically this part here is just screwed and unscrewed, and then you can take this out and they will fit on all of those here. That's basically how we did this. They were used, this is an R&D setup for research and development. I remember those. And this was, I have to thank the Bosch person who sent me that stuff. This one here, and you can see this has a mark of 8 on it. And it goes to 16, but 8 is the red mark. And this was a pressure range which they used, I shouldn't say we used, they used for fuel pump testing when they developed fuel pumps, because the fuel pumps can go by far over 8 bar. I think the highest they can go is 14, depends if they are paralleled or in series, if you have a one pump or two pump system. And this is basically what they use to experiment with these pumps. And these connectors, these quick disconnects they have on here for the pressure lines and the pressure lines itself, they can hold up to 50 bar. So this was a highly versatile system. And you can then basically build a setup to whatever you want to test or develop. This one has a few scratches on it. I have to polish this out. So that came actually out of a working environment. These are Bosch made in Germany, in Stuttgart, and they were not for public sale. And the other ones I got from an automotive place in Wisconsin, because that's where their main thing is. You can see this is a 16, this is a 15. The 15 goes to 10 bar. And I see they're basically brand new, but they're quite old too. Here you can see this again. They have now a slightly different connector style than this here. So they can be coupled either way on these here. There's quick disconnects for this style, and there's quick disconnects for this style here, what they have, which is this one here. So you can see this, and this goes to 2.5 bar. So these are the two I got here for the smaller pressure ranges. And I got these ones here, which are 012s. If I can get it out. And that goes to 6 bar. Now, our friend Kent Bergsma did a very nice video he posted, I think, either yesterday or today. And he showed the difficulties he had with getting good working pressure gauges. Because really what you need to do is, before you can test anything, you always should check your test equipment before you test anything on your car, to make sure that the test equipment is working and that they're showing the correct pressure. Because otherwise you're trying to troubleshoot something, and if the pressure system does not work, then you're gonna have a problem. The other thing is, if you ever get a Bosch part, let me, with Kent, I'm gonna put the link to his video he made today, because I think that is very important what he's showing, in the description of this video, so you can watch this if you haven't seen it yet. These Bosch parts do not have the date code on there because they were not for public. They do not have serial numbers, and they do not have dates, manufacturing dates. The only way I could determine this, how old they are, is by the zip code. You can see this D for Germany, Deutschland, 7000 Stuttgart. This was our zip code, and in 1993, I think it was to July 1st, 1993, Germany, because of the reunification, had to change this from a 4-digit zip code to a 5-digit zip code. So whenever you have a package where you have a company, whether it's Mercedes-Benz, Porsche, Bosch, any one of them, and the zip code has only 4 digits, then you know that this part was made prior to July 1st of 1993. So we got us some real rare original Bosch stuff. This stuff is priceless, basically. I do not want to say how much I paid for it, but I was pretty lucky. From my days at Bosch, or when I was working with Bosch, the preferred ranges were these accurate, from what I remember, analog instruments. So these type of analog instruments have the highest precision in the middle. So this one here has the highest precision between 2 to 4 bar, where this one here would go for about 4 to 6 bar. And this one here with the 8 bar mark would be between 6 and 10. So I do not know how this is with these meters we get, or the pressure gauges we get today. This one here would be right between 1 to 1.5. So you can see you can measure with very high accuracy with these gauges here. The way you can identify the authenticity of a Bosch made for internal use only gauge is by the numbers, by the green Bosch sign in here, PSI and bar for both. And they have 2 screws where you can take this out, and there is a calibration set screw in there where they can be actually calibrated. And the way they are calibrated is you apply a known source of the pressure at the center mark of the scale, in the center of the scale, and then you can adjust this. So even when they age over time, you can calibrate them exactly to the position, and then the tolerances of those are going to be 1% or less. So they're highly accurate, and they can be calibrated at any time for verification, that to make sure that you're working with absolutely correct instruments here. They're high precision, Bosch made in Germany, only for Bosch internal use. On certain items or test systems which were delivered to subcontractors who made parts for Bosch, which didn't happen very much in the 70s and 80s. Let me just see if I can get this a little bit better here. These are basically what we consider class 1 instruments. And the way Bosch did this, or the classification system we have, was basically like this here. Let me see if I can get this paper over here. I put that here. We make a triangle like this here. The top of the pyramid is R and D. The second class, these ones have the highest tolerance, is manufacturing. manufacturing, calibration. This is what they would have used. So this is class 1, class 2, class 3 is service. Service, and class 4 would be consumer. And the reason why this is a pyramid is because of the quantity in which they were produced. So they built a lot of those which have a low tolerance. These were the kind of gauges you would put into your Volkswagen, into your Golf, Scirocco, whatever, RPM type gauges, battery type gauges for, charging and that sort of stuff. The service ones, these are the ones you would see if they have a pressure gauge, like what they would sell. They have a medium tolerance. Class 2 has a very high tolerance. And they have ultra low, ultra high tolerance. And this is what those are. So they're going to have better than 1%, better than 2%. They're going to be at 5%. And here you're going to be at a range of 10% to 20%. Bosch offers those style of gauges now, which are made by Bosch China for end users, for whatever you want to put it in your car to monitor pressures, oil pressure or what have you, that kind of stuff. These gauges here, they can take both fluids and air, compressed air. You can test both with them. So this is kind of on how this worked, and this is the difference. I do not know on how difficult. I'm pretty sure that they were quite expensive when they were made. You can also see they don't have a bezel around it. So if they were put in this here, like in this configuration, they would have this here mounted, and then they would have another plate with a cutout with a round hole, which would match this if you wanted to cover the backside. But the whole purpose was the accessibility and the rapid redirection or connecting and disconnecting of lines, feed lines and the pass lines or whatever for an R&D setup. This is what this stuff basically looks like it. So we got some real good goodies here. And with these units, I will incorporate them in our calibration system for demonstration purposes. You probably can buy American-made or European-made instruments in these classes here in the top one. They're probably going to cost $200 to $500 a piece if you really wanted to do something extraordinary. I'm doing this here not so much to impress people, but to document this for people who are interested in this. The Bosch Jetronic system, especially the K-Jetronic system, was requested or developed by Porsche in the first place. And this is a ultra high precision fuel injection system for high performance vehicles. So this is not a carburetor. This is when it is properly tuned. You can adapt this to any engine you want to adapt the system to. And you have the ability, because we can adjust the flow rate on the fuel distributor, to say like, if you wanted to increase the performance of your engine, whether it's a 5-liter engine or 5.6-liter engine, if you put the oversized pistons in there, and you change your valve timing and everything else, you can then also adjust the amount of fuel going into this to come, to increase the performance. You can really tune the system down to the dot, where this is almost going to Formula One levels in terms of precision in racing. And this is why this stuff is so expensive. They adopted this because you can also do this for fuel efficiency, and with fuel efficiency came the environmental thing. So you can do it both ways, either high performance race type environment, or you can do it for fuel economy and environmental pollution control. The interesting thing is, if you look at the Lamborghini or the Ferrari boards, or Porsche for that matter, where you deal with race cars, literally with ultra high performance cars, who have the K-Jetronic in there, and they really went for this stuff hook, line, and sinker. You never hear a complaint about it. There's no one whining on these boards about the K-Jetronic and how difficult it is, and this, that, and the other thing is, because that is what gave those cars the performance. This system, the K-Jetronic, made the 450 SEL 6.9 the fastest limousine or production assembled vehicle in the late or mid 1970s, and outperformed everything and anything on the market, even though that thing weighed almost over 2 tons with a maximum speed of about 225 to 250 kilometers, somewhere in that range per hour, which was unheard of until that time from a assembly line manufactured vehicle. This is where this is at. So this is one of the best fuel injection system, as not just a pulse one, continuously, because it can be easily adapted to any type of engine, and you can adjust the flow rate, not through software or anything else, simply by calculating the math of how much fuel you need for your piston sizes and the stroke length and all of that stuff, and your compression ratio and the fuel you're using, to get the optimum performance in terms of horsepower out of the engine. This is something I wanted to mention here. So this is where we got, and these are the instruments which were used in those years to get there with this stuff. So this is what I wanted to share with you. And you will see these in action as we're going to get and build the whole calibration system for the K-Jetronic fuel distributor and the KE distributor. And that is now the first segment of the video. And now we're going to go to the second part of the video, second segment. Okay, so now we're in the part 2 here of this, and you can see I got the new hoses came in from Mercedes-Benz. And these, I had them in the freezer. I just took them out. It took me 5 minutes to find them because I forgot I had put them in the freezer. And let me see if I can zoom in here. These ones here are actually made by L-Ring. It's hard to see, I know. But this is the company sign for L-Ring as a manufacturer who makes them for Mercedes-Benz. And you can see they're getting hot. They're getting, at 20 degrees, they're pretty hot like the other ones I got. So they came in and they cost me $14. These are the Mercedes-Benz parts, which I believe are recycled rubber. I'm pretty certain that they are almost. And just to let you know, so $14 or $17, they were $34. And it looks like that they may have to be just replaced, say like every year or maybe every 2 years, depending on where you are with the climate. Here in Kansas City, with the car parked outside in that cold weather we had, they last about 7 months, 8 months. Basically winter, summer, and then in the middle of the summer, they usually starting to leak. I'm just taking this now as a part of life, and that we just have to replace those. They're not difficult to replace, but that's just part of it. And at $14 or $17 a piece, it's not a big deal. So L-Ring is the manufacturer who makes them for Bosch. I don't think, not for Bosch, for Mercedes-Benz. I do not think that they were actually the ones who made them back in the 1980s when they were installed. But Earring, as many other companies, were bought, and they merged because they consolidated so many parts businesses for the automotive industry, and that may come from another one, and that was actually it. But this is pretty certain. I'm certain that this is recycled rubber, and the reason for this is environmental restrictions and the availability of virgin rubber, from Asia primarily. The biggest, and Brazil, I think, is another country which manufactures virgin rubber. They have the rubber trees, basically, which can make them, but the demand for rubber is so high that they may have gone to recycled rubber, and that probably is reflected in the price too. Like I said, it's for $14 or $17 from Mercedes-Benz. That's a drop in the bucket, and that is just a maintenance item you have to replace now the same way you replace your oil filter, once a year. That is just something we have to live with. Not a big deal. I just keep ordering them and put them in, and I don't have any problems. Times change, parts change, environmental things change, so that is something we have to live with. That's just, I wanted to show you this, that they came in, so I have already the replacement. Are they working better than the Truck Tech parts I have? No, because you saw the cracking at the ends here I got on this side here with the caps from after I had that cold on the Truck Tech parts. That means they're too tight with the holes, and the rubber is not temperature stable either, looking at the issues involved. So this is our last segment for tonight, and these are now the digital flow meters, which give a pulse when a certain amount of fluid goes through them. This is the Japanese made one here, which I got for $20, and I have not tested them yet. And I contacted Sayo in China. That is one of the main Chinese companies which makes those, and I'm going to explain this, and the reason why I did this is because Sayo, I got them from the manufacturer directly in China, and they say made in Chen. Oh, that's the model. Sayo sensor, you can see this. Everything on here is on here, and they're basically Chinese made, and that is the Chinese brand name. These sensors here, this here, and this here are made by Sayo. And that is a domestic Chinese company which manufactures only flow sensors. The way this normally works is, say, like you have an American or European company who wants to have a product made in China. They usually contract with a Chinese assembly or manufacturing company which develops the product or can build every part to a product and assemble then the finished product. This here is a company, a Chinese company, which makes only sensors. They don't assemble anything, and they don't sell normally to the United States. The only way you can purchase these is via Alibaba or AliExpress. I contacted them directly, and I purchased this via PayPal from that company. I talked to their sales manager over there. It's not a big company. And their primary customers are Chinese companies who build everything that has to do with water. So water purification systems, coffee makers, whatever the Chinese people use in their own country. And I wanted to see what this actually looks like. What do domestic Chinese companies buy in for parts for their products they're selling only in China? Just to get an idea, because it is very different of what we're getting versus what they're using over there. China is the biggest domestic market from a consumer point anywhere in the world. And of course, the Chinese people are very patriotic people, and they embrace made in China, and usually the quality is higher for the things they're selling within China. The cost of those parts were relatively low because it is a high volume consumer-based end product where they go into. So this one was like $3.90. This was like $4.20. And these were a little bit higher. This is their smallest one. And the way they work too is they have a Hall effect sensor in there. And they're basically having a turbine, which is somewhat hard to see. Let me see if I can get the light behind it. And we should be able to see something, hopefully. You can see it. It's like a water mill, basically, the way that goes through it. And they put a pulse out for every amount of whatever cavity they have in there, and it will advance it. So this is how you know you're counting the pulses coming out of this thing. And by knowing, you have to look at the data sheet. It will tell you for each on this type on how much volume of fluid this actually equates to. And the problem with these here is the flow rates need to be higher. They need to be about 50 milliliters per minute at the very most, even for the small ones. They don't make anything that small to do 4 milliliters or 6 milliliters. We actually need for the calibration. Here you can see the little turbine really well. The units, I think, handmade. You can see the markings here when they were put in a vise. I guess when they assembled this here, when they screwed this on and inserted the little turbine in here, they were clamped in, and you can actually see that they used regular tap water in the testing process when they were actually checked that there's a water stain you have on here, which is high in calcium. So they are of decent quality. For the price, this is something you could never make here. The process, what I'm going to do is, all of these sensors basically work the same way. They have a 5-volt supply, which is the red wire, then a ground connection, and the yellow one is the pulse, which is going to be, every time you get a pulse, the pulse is going to be between 3 to 5 volts. The same as with the Japanese model, and you can see the connectors actually meet up. So we can make one circuit board, which is on the way of being designed as we speak. And I went with 7 segment displays to do this. I will present this when it is done, and then we can start putting this together. The flow rates, we're looking at 4 milliliter per minute, 6 milliliter per minute at idle speed. With a resolution of these sensors, they should be 0.1 milliliter or 0.01 milliliter. Is medical grade, because that's where you usually do the scientific medical. And the real high quality ones made in the United States, Japan, or in Germany, Switzerland, Austria, they start at about $2,000 a piece and go to over $12,000. That is one thing which has not changed. Aalborg, the company which makes the water meter, they also have digital sensors, flow sensors, but the resolution is too low for what we're looking at. So I will experiment with these here to get a feel of a flow rate and how they're indicating this, and if they really need a very high flow rate, or if they actually would work with lower flow rates, and then see what kind of accuracy we get. The beauty about digital sensors is this, and that's why I did that project for Bosch for this stuff back in, I think it was 87 or 88, was because we can change the sensitivity through the software, the way we write, or I would write the software out. And then I can also, do a whole bunch of other things by knowing the sensor. So the circuit board with the display on it is going to be universal, and we can interchange sensors and see which sensor actually will work better for our application, and we will get at a low cost or lower cost to the desired results with this stuff. I had never bought any Chinese made products, components or parts, which were exclusively for the domestic Chinese market, is what you're seeing here. They're not copied from any other company. They developed their own sensors, like I said, as they built nothing but sensors. And they got a wide variety of them in plastic and in brass and then different types of plastic. And the overall quality itself is fairly decent, I have to say, especially for the price they have, and that they're all assembled by hand, basically. They got all them Chinese ladies over there putting all of the stuff together, and they're testing it. In manufacturing in general, the parts and putting that stuff together is the lowest part of the cost of building something. The cost really comes in with the testing, and is more elaborate the testing and the calibration is more expensive the product actually gets. Of course, if you start out with high quality base components, plastics and bearings and that sort of stuff, what these things have inside of them, then the ultimate end result will be, of course, a higher quality product. But with the digital world, you can compensate in software for a lot of little imperfections in these. And this is something we're going to investigate. And I will see which sensors we're actually going to wind up with. And if the cost is low enough, we will sell this as a kit to you, where you have to assemble the circuit board yourself, the one I'm developing right now, and then you can choose your own sensor and if they're within a certain parameter range with these type of connectors on here, and you will be able to actually have a full-blown calibration test system for, say, like $100 or $200 in that range to adjust your fuel distributor to the highest precision possible, which by far outperform the rotor meters, because the analog meters and analog always has a lot of drawbacks in terms of precision and readability and repeatability. So that's basically what the goal is. So since I regaining my strength here, it will take a little bit longer, but eventually we will get there. And again, I would like to thank all of the subscribers and viewers who viewed my community post and who wished me well-being. It is greatly appreciated. And again, you guys rock. And with that, you have a great night.